Welcome to IS 300 and today's discussion of Chapter 1, Enterprise Computing, a Retrospective. In this chapter, we will go through an introduction, then we'll talk about mainframe architectures, client-server architectures, and three-tier architectures. The more things change, the more they stay the same. You may have heard that phrase, and it is applicable to what we're talking about today. We talk about the evolution of large systems, large centralized computing systems. In the 60s, the mainframes evolved to distributed computing architectures and client-server systems in the mid-1980s. Then in the 1990s, we migrated to web-based enterprise applications and customer-facing e-commerce platforms. Many of you do not remember a time when there was no internet, but in the mid-1990s was when the internet came on the scene in the mid-1990s. And as a result, it changed the way we did everything, and we have not looked back since. Enterprise computing is defined as the use of computers for data processing in large organizations. The enterprise is simply the components, the hardware, the software, the network, the stuff that is required to run an organization. Enterprise computing then is the use of computers for data processing in large organizations. Cloud computing has transformed computing itself into a utility that can be accessed over the internet. Before cloud computing, companies were strapped with the requirement to upgrade. Upgrades were very expensive. They required a lot of downtime, and they required day-to-day operation to be sustained while the upgrade was happening. Very disruptive and usually very expensive. And cloud computing has changed all of that because you can simply purchase resources as a commodity, just as you would any other utility. And so it has become a utility like the electric bill, like the phone bill. It's just a bill that can be paid for. You pay for what you need when you need it. So the rapid provisioning is on the vendor's hands rather than on a company's hands. They don't have to maintain a staff. They don't have to maintain the hardware. They don't have to purchase hardware. They simply pay for a service. We'll talk about those services: software as a service, platform as a service, and or infrastructure as a service. Those are the most popular cloud computing architectures, and we will talk about those in great detail in this course. There is a pricing model so that, again, consumers only pay for what they need when they need it. Mainframes. Back in the day, all we had was mainframes with a connection, a dumb terminal, a thin client, if you will. And a dumb terminal, basically the difference between a fat client and a thin client is the thin client is just a connection, an internet connection that doesn't have a CPU. The fat client, on the other hand, has a CPU, but at the same time, it has network capability. So you need network capability with the thin client and the fat client. Difference is all of the processing with a thin client, it happens on the mainframe or on the server, if you will. And with a fat client, the processing can happen on the client or it can happen on the server. Fault tolerance has to be built in if you are a system that cannot afford any downtime. You work for a company that needs uptime 24/7, 365. The fault tolerance must be built in. With mainframe architectures, the fault tolerance was built into, they had multiple processors, multiple replacement parts, hardware, software, and or multiple redundancy built into their networks. And that, if you think about a company such as Bank of America, where the bank cannot afford any downtime, they have servers that are multi-processor, symmetric multiprocessing usually on the server. They have redundancy with their networks, distributed computing environments, and replication, so that a transaction happens at one location, it is replicated to other locations, so your account balance, for example, is always up to date, regardless of where you go and where you are anywhere in the world, and those systems are up 24/7, 365. You can connect to them through a terminal, through a smartphone, through your tablet PC, or you can simply go to an ATM and gain access to those systems. We've gone full circle. We started with mainframe architectures with non-relational databases. Then we migrated to relational databases. And now we have gone back to non-relational databases. And we will talk about that when we get to the chapter on database development. Centralized computing, if you're talking about a mainframe, you think about a data center where there was very large computer hardware and lots of cables and wires, usually under the floor. There is a whole group of computer operators and administrators and technicians and people that have to keep those mainframes up and running all the time. Same thing happens with the cloud computing environment. The difference is that you don't have to maintain that hardware. You don't have to maintain the facilities, and you don't have to maintain the staff. If you are using cloud computing, you simply rely on the vendor to provide all of those resources, and you pay a fee for using those resources. Much more efficient for the company. With client-server architecture, the microprocessor, the Intel chip, if you will, changed the way everything was done with computers. In mid-1980s, or around 1982 to 84, the personal computer was put on the market and was deployed to business desktops and homes. And that personal computer then was a standalone unit. In some cases, there was networking capability. But remember, the internet didn't come on the scene till the mid-1990s. So the PC was around for about 10 years before the internet came on the horizon. So most of those PCs were standalone devices that, in the case of companies, you had networking capability, but you emulated the dumb terminals of the 60s and 70s by using software that you installed on the PC, which allowed you to connect to a mainframe. Then you had data processing tasks that moved away from the mainframe to the small but powerful CPU on a PC. And so software like Lotus 1, 2, 3 and those kinds of softwares became very popular. They were redundant because every person in the company would have a license to use Lotus 1, 2, 3 or a tool like Microsoft Word or something like that. And so it was, you could buy a license, a site license, and use, every computer could then take advantage of the site license, but that software had to be installed on each and every one of those computers. The graphical user interface, the GUI, forms model, evolved the first client-server architecture and became a tool that could be used for, so you use the GUI, you log on, you connect to a GUI, The GUI then allows you to connect to a system. That part is still in place today. The difference is that this connection was probably through a terminal emulation networking capability as opposed to the internet that we are using for cloud computing architectures today. So we had a graphical user interface as opposed to the terminal-based character user interface. If you've ever used MS-DOS on a Windows computer, you have used a character user interface. Here's a diagram that shows the forms-based architecture, which is the architecture that we're familiar with now. Basically, you had a terminal and or a PC with terminal emulation software on it that allowed you to connect to a server or a mainframe or wherever the application was located. And you used an RS-232 connection. You connected to a character user interface. Maybe you connected to SQL if you're running a graphical user interface, and you used a form-based architecture. You had the application logic on this server. You had some stored procedures or business logic and a relational database, either Unix or Windows NT, or some sort of server that was connected, allowed the connection from the server to the PC and or the terminal using terminal emulation software. The FAT client then gave you the ability to connect using an application that was running on the PC and probably connect to a SQL server or something like that to a relational database, and the form was basically built into the application. Client-server architecture. Some of the problems of the client-server architecture was that you had, if you needed to upgrade, you had, let's say you had 500 computers in a company. Each one of those computers would have to be upgraded. The versions and the instances of that upgrade would have to be deployed across multiple systems. Usually the upgrades took hours to do. You could use imaging software, and now we use virtual machines, and you deploy the virtual machine, and then when the user brings up the virtual machine, the upgrade has already been configured. So you don't have to touch any one system manually. You simply deploy an image that's already installed on a virtual machine. Scalability is an issue with client-server architectures because it was very difficult to upgrade and or downgrade. There wasn't a lot of need for downgrading, but it wasn't something that could be done easily. Then we got to three-tier architectures. The layered approach became the way to do business, and you had transaction processing monitors that were used to solve some of the load balancing problems created by the client-server architectures. And the transaction processing monitors became the first example of middleware. We will talk quite a bit about middleware in this course. Middleware simply allows one system to communicate with another system, and the translation happens through the middleware. And so in the case of the transaction processing monitors, the middleware sat between the client and the database server, as it does now, and it was able to manage and control the load balancing. It queued the client request, and those client requests were referred to as services, and they're still referred to as services today in the cloud computing model. The transaction processing monitor became known as the three-tier architecture model, with 3 layers. The client layer, some people call it the presentation layer, or the application layer. Then you have the business, which has the logic running, the application typically running on the client now. If you're talking about the OSI 7-layer reference model, the application layer and the presentation layer were interchanged. If you're talking about a 3-tier model, the application layer is typically the second layer, the business layer of the 3-tier architecture. And then the bottom layer is the data, which is stored on a database server. The layers are separated, and sometimes they reside on different machines, different servers, if you will, but not all the time. Sometimes all 3 layers can be on the same machine. The benefits of the 3-tier architecture is the separation of the user interface and the business logic. And if you were talking about cloud environments, usually the client was a browser. Load balancing typically was part of it to manage the high transaction volumes. Server farms and load balancing servers are part of what happens with a 3-tier architecture. 3-tier and or N-tier, multiple tiers. 3 or more tiers is what we're used to today. And then the introduction of object-based access to services, which replaced remote procedure calls. So in technology terms, an object is a noun. A noun is a person, place, or thing. An object in this case is something that can be programmed, such as an account can be an object, a customer can be an object, a hardware device can be considered an object. All of these objects are typically manipulated by using code to program. Object-oriented code is simply the manipulation of these objects. So this bottom line is that, again, the more things change, the more they stay the same. So mainframe computing and cloud computing are pretty much have gone full circle with virtual machines that are being used and deployed all the time. Makes life very simple. You configure the virtual machine, you deploy the virtual machine, the user opens the virtual machine, and they've got the configuration already set up and they're good to go. Graphical user interface, which gives you the ability to put your data into a form. We use GUIs every time we log on to a Blackboard, for example. You type in your username and your password, you're typing it into a form. You hit the enter key, you're sending that form across the network to a server which validates, and then you gain access. If you have the right username, if you have the right credentials, you gain access. That access then is dictated by the configuration and your permissions that have been set up on the system by an administrator somewhere before you even begin to log on. That configuration is already in place. So we use forms all the time. Every time we log on to a website, we are using a graphical user interface and a form. Layered architectures, 3 layers. If you're talking about the standard 3-tier architecture, the client layer, the business layer, and the data layer. Client layer, also known as the presentation layer. If you're talking about the cloud computing environment, the cloud layer, or the client layer rather, relies upon a browser to connect to the internet. Cloud computing is now a utility which companies use to pay for their service based on their usage. It's just another utility like their electric bills, their phone bills, things of that nature. And so we will get into the architecture specifically in Chapter 2. Please let me know if you have any questions.